So if you answer quickly, we can go to the following topics. So what about A? Is it one-dimensional motion or not? Anyone? What about Jayashri? Come on, quick, ma. Soumya, you are present?
No, sir.
Yes.
Not a one dimension, sir.
Okay, not a one-dimensional motion. The reason?
Because it rotates twice, sir.
What?
Twice it's coming, sir.
No, I couldn't get you. Sorry. That is two positions at the same instant. That's what we have seen. Have you remember? There is two positions at the
Yes,
same
sir.
time. Yeah, from here, for this, and this. Okay, in these instances, okay, let's say this is 1, 2, 3, 4, and 5. Okay, so in these instances, there are two positions here and here, and here and here, here and here, and here and here. Okay, so there are two positions at the same instance. Okay, so what about B? Anyone? Jayashri or Soumya?
One dimension, sir.
For B, it is a one-dimension motion or not? Is it one dimension?
Yes, sir.
Your good name?
Soumya, sir.
Soumya. Okay. Actually, it is not a one-dimensional motion. Okay. The second graph is also does not represent a one-dimensional motion because Jayashri, can you give him some? Can you answer this? Because you are present, no? Last class. I can't ask Mrinalini because she is B is not a one dimension because two position at one instance. Yeah, but not two position Mrinalini. Mrinalini says it is two position at an instant. Okay. It is not a one dimensional motion because there are two velocities at the same instant. See, this y-axis represents the velocity only. Okay, Mrinalini. So it represents two velocities at the same instant. So it is not a one-dimensional motion. What about 3? That is C. Sorry. What about C? Come on, quickly, ma. We have, I don't think Vishwant attended the last class. So Soumya has attended and Jayashri attended the last class. Mrinalini, she will use the chat, no problem. Okay, you could use the chat. But this 3, Jayashri, Mrinalini and Soumya, just answer the questions so that we can move ahead quickly. So what about C? Does it represent one-dimensional motion? C, speed cannot be negative. Very good. C is not a one-dimensional motion because speed is negative here. Speed is what? Always. Speed is always what? Positive. Here speed becomes negative, which is not at all possible, right? Okay. So it is not a one-dimensional motion. What about D? So it is not a one-dimensional motion. Okay. What about D? Soumya and Jayashri. Soumya and Jayashri. Is my voice clear, ma? D is not one-dimensional motion because the distance decreases. Very good. So the total path length, okay, here it decreases. Okay, it is 0. It increases to certain level. Excuse me, the student is just joining now. Please excuse me. Disha, welcome to the class.
Good evening.
Good evening, ma. Good evening. Welcome to the class. And we were discussing, yeah, this one. What is D? D is a one-dimensional motion or not? Mrinalini said it is not a one-dimensional motion. because the total path length, that is the distance, decreases. For instance, this is 0 meter, let's say this is 20 meter. Okay, so it has went to 20 meter. Let's say it has come to let's say 0 to 20 meter. Okay, so the body started at 0 meter, it reaches 20 meters. Okay, from here it reaches another, it reaches this position. Okay, so what is the total distance covered? That is here. It should be added, this 20 meter plus this 20 meter, right? But here it shows it, the distance decreases. Okay, from 20 meter it comes to here, that is, let's say this is 15, 15, 10, 0. So distance can never decrease. Okay, when a body is in motion, distance can never decrease. Okay, so D is not a one-dimensional motion. Okay, thank you. So we'll move to the next sum. We have a sum here. So they have given xt graph, okay, position time graph in one-dimensional motion. They have given 3 different equal intervals of time. Underline the point. 3 different equal intervals of time. Yeah. So, excuse me. Okay, 3 different equal intervals of time are shown. So, in which interval is the average speed greatest? So this is one interval. They are given 3 equal intervals. This is an interval, and this is an interval, and this is an interval. Okay, nothing but a time. Let's say this is t1, t2. This is t3, t4, and this is t5, t6. Okay, for examples, they are asking which interval is the average speed greatest. Can anybody tell in which interval the average speed is greatest? So what is the average speed formula? What is the average speed formula? Anyone? Disha? Come on, you can answer quickly. These are things that we already know.
Total distance by total time.
Okay, average speed is nothing but total distance by total time. Very good. Total distance by total time. They are asking in which interval is the average speed greatest, whether for this interval or for this interval, which will have an average speed as greatest, first, second, or third. Anybody? You can try.
Second, sir.
Second, just a moment. Some student is joining just now. Nitish, welcome to the class, Nitish. Good evening. Okay. So, Disha, right? Disha, you said it is second. What about others?
Soumya, sir.
Oh, sorry, Soumya. Okay, thank you, ma. You said it is 2. Okay, the second interval. What about the, what about others? Anybody? Soumya said it is second. Second interval is the greatest. In the second interval, the average speed here is greatest. That's what Soumya said. In the second interval. Anyone? Jayashri or Disha? Even Mirnalini, you can chat if you're available. Nitish, you can also try. Do you have any different answer than Soumya? Okay. See, the greatest should be the third interval. Okay. The greatest, in which interval is the average speed greatest? Nothing but the third interval. So why, sir? As you already know, average speed formula is what? Total distance by total time taken. Let's say this is position 1. Okay, this is the first position. Let's say the interval, first interval. let's say this is a position 1. Okay, here this is position 2. So the distance, compare the distance. Okay, so this is the distance here. I'll write in, let's say I'll write in a different color. Okay, this is position 1, this is position 1, and this is position 2. Okay, now this blue color, no, this is the distance that covered. Okay, this is the distance between position 1 and position 2. Okay, now for the second interval, writing as this is position 1 for the second interval. Okay, and the position 2 is here, somewhat here. Okay, this is the position 2. Okay, and the distance between the position 1 and 2 is this one. Okay, this line. And similarly for the third interval, this is the position 1, this is the position 1. Okay, and this is the position 2 here, somewhere around here. Okay, this is the position 2, and this is the, sorry, this is the distance. Okay, sorry, this distance between position 1 and 2. Sorry, I couldn't do it in a straight line. I'll try. Okay, yeah, so sorry ma, just a moment. Yeah, so which has a higher distance between the position 1 and 2? Which has the higher distance? Whether this distance is large, or this distance is large, or this distance is large. Which has a larger value? First, second, or third? Which
Third,
distance?
sir.
Third, yeah. So the total distance will be higher for this interval. Am I right?
Yes.
Yes. So the average speed is, highest, that is greatest. Okay, greatest in this interval. Okay, and they're asking which it is least. Tell me which it is least. So this is the highest, this is the greatest. Okay, average speed will be greatest 1. Bernali says it is 1. Anyone? In which interval the average speed is at least? Which has the least value? 3 has the greatest
One.
value. There be, excuse me, ma.
One.
1. Your good name?
Soumya.
Saumya. Okay, so Saumya and Mrinalini, they share the same answer. They are saying it is 1. Okay, actually it is going to be 2. Okay, because as we see, let's say I'm, for just an example, I'm saying this is somewhere like um, maybe 5 meters, and this is somewhere like 7 meters. Okay, so this is nothing but what, 2 meters. But here, as you can see, if you have a book you can see it. Okay, this is here, and the second position is very closer. Okay, this could be just can come like 1 meter. Okay, so the distance which is least in which interval? 1 or 2? In which interval it is least, the distance? Come on. Do you understand or not, ma?
No, sir.
You don't understand? Okay, see here, the initial position is here. Okay, the final position is just, not very not very far. This is the initial position, right? This is the final position. This is not very far, but here the initial position is here, the final position is here. Okay, which is somewhat, which has the higher distance, which has the higher distance between the initial and the final position? In which interval? Can you say?
One.
1 has a higher distance, right? Very good. And let's say we can say the distance of 1. okay, is greater than the distance of 2. Am I right or not?
Yes, sir.
Okay. And the question they said that 3 different equal intervals of time. So this interval of time is equal. Okay. Let's say it is 2 seconds. It is also 2 seconds, and here is also 2 seconds. You understand? So they are equal intervals of time. So when will the average speed be least? When distance is least. Am I right or not?
Yes, sir. True.
Okay. So which has the least distance in this time interval?
True.
2. Okay. So 2 is the right answer. Okay. The least distance. Okay. The least distance is in the second interval. You understand? The greatest is nothing but the third interval. Okay. So they're asking, give the sign of the average velocity for each interval. Give the sign of the average velocity for each interval. So try to answer that question by yourself. You can do it actually. You know the answer. So what is the sign of the average velocity for each interval? Just tell me. What will be the sign of the average velocity? What is the average velocity formula? What is
Total
the average velocity
displacement divided by
formula?
total time.
What?
Total displacement divided by total time.
Okay, displacement by time interval, del x by del t. Okay. So when can the average velocity be minus and when can the average velocity be plus? Average velocity depends on the del x value. Am I right? So what is del x here? X2 minus x1 divided by del t is t2 minus t1. You don't have to be worried about del t because they have given it is only equal intervals of time. Okay. So you have to be worried about the displacement only. What is displacement? Change in position, that is x2 minus x1. If this is x2 minus x1, that is del x. Okay. If del x is positive, then what happens? Average velocity will be positive. If del x is negative, what happens? Average velocity will be negative. Okay. So by that, you just give us give us the sign of average velocity for interval 1, interval 2, and interval 3. I'm just erasing it, no problem. Okay, because you'll get videos. This class is recorded only, as you all know, so you can get videos. Okay. So tell me, the average velocity, sign of the average velocity for first interval is what? Sign of average velocity. Excuse me, ma'am. Just a moment. Savior. Okay. I think Mirnalini says first is positive, second is also positive, third is negative. Okay. She has given the very good. First is positive. Very good, because the x1 is here. This is x1 and this is x2. So x2 has a higher value than x1. Okay. So x2 minus x1, or I can say like this, x2 is greater than x1. So del x will be positive. Okay. All right. So what about here second one? What you said, Mrinalini? You said plus. I think Mrinalini said plus. I guess sign of average velocity is plus. I guess.
Sir, what is del x?
Del x is nothing but, just a moment. Del x is nothing but displacement. Displacement is nothing else, change in position. Okay, change in position. So the change in displacement is nothing but change in position. Okay, and it is denoted by del x. X is nothing but position. Okay, and del is nothing but change. Okay, so del x is equal to x2 minus x1, nothing but del x is displacement. Okay, so x2 is the final position. Okay, x1 is the initial position. Okay.
Yes, sir.
Okay, so actually I just don't know whether about, I'm not sure about the second one. Okay, because this picture is not quite you know bigger. Okay, so you just have to check on your books also. I'm just I have a doubt whether this position is equal to this position or not. Okay, by the diagram there's only negligible, only it's very negligible. It could be even there is a possibility, I don't know, there is a possibility that x2, that is this is x1 equal to x2 also. Okay, let me check and tell. Okay, whether in this question the image is given as such. If you have books you can also check. This is an NCERT problem only, whether that the x1, whether that x1 seems to be equal to x2. Do you have books? Do you have NCERT textbooks with you? There's a possibility, so you'll be okay. You can just verify if you want, because here there is a position. Here also I think it is, because the curve is like this. The curve, no curve is like this. So maybe this is the first initial position. It could be the final position. So there is a possibility that it is equal. You cannot say that. Okay. Or else I can, just a moment. I do have NCERT book. I can check it for you. Just a moment. No, no, it's not x1 is equal to x2. Sorry, it is slightly different. Right? So this is x1, okay, and this is here. It is x2. They are quite different places. Slightly they differ only, but here also x2 is greater than x1. So what happens? Del x is what? Del x is what, ma? Del x is nothing but positive, right? Del x is positive, so average velocity is also positive. Okay, so second is also average velocity in I'll write like this. Average velocity is positive in second, and first also average velocity is positive. Okay, what about third?
Third is negative, sir. X2 less than x1.
Okay, so this is x1, right?
Yes, sir.
And this is x2.
Negative.
Yeah, very good. So x1 is greater than x2. Am I right? That's what you have said. X2 is lesser than x1.
Yes, sir.
So here you can say that yeah, x2 is negative. Okay, and x1 is also negative, in the negative position only. But x2 is, as you said, x2 is lesser than x1. Okay, x2 is lesser than x1. So when you put like del x is equal to x2 will have negative sign, so minus of x1. Okay, minus of x1. Okay, so del s, this will yield a minus sign, and this also will yield a minus sign, so the result will be minus only. So del x, that is the change in position, del x displacement will be negative. So in turn average velocity is also negative. Okay. So do you have any doubts here? First, second, and third. Do you have any doubts here? Anyone? Or else we can proceed to the next one. See, I have erased all my, writings here. No problem. This class, every class is being recorded, right? You know that. So you can view it at your own time. Okay. So yes. Do you have any doubts? We can proceed. Shall we proceed?
Yes, sir.
Right. Okay. So the next concept we are going to see is acceleration. So acceleration, okay, that is the velocity of an object, okay, changes, okay, during its course of motion, okay. Velocity of an object changes during its course of motion. For example, if you are riding a bike, okay, or yeah, if you're riding a bike, okay, you're traveling in a straight road. So you're starting the bike, you're starting at 0 meter per second, or else we can define by the 0 kilometer per hour, okay. And after some time, what you do, you give an acceleration, okay, then you go to what, 20 kilometer per hour. Then what happens after some time? If the road is free, there is no traffic, what you'll do, you'll further accelerate, you'll even go to 60 kilometer per hour. So in your motion, your course of motion, okay, you tend to change your velocity. Okay, when you're moving, you tend to change your velocity or speed for that matter. Okay, so there is a change in velocity. So how to describe this change in velocity? How to describe this change in velocity? Okay, so that gave to a concept of acceleration. So a body's velocity tend to change, okay, with respect to time. A body's velocity tend to change. So how to describe this change that happens in velocity or speed? So that gives rise to the concept of acceleration. Okay, so acceleration is nothing but, its definition is nothing but rate of change of velocity, rate of change of velocity with time. Okay, acceleration nothing but rate of change of velocity with time. Okay, so I'll just erase all this. So what is the definition of acceleration? It is a rate of change of velocity with time, and its unit is nothing but meter per second squared, or meter second to the power minus 2. Okay, so acceleration, as we speak, it is also what, it is nothing but a vector quantity. It is a vector quantity. What is vector quantity? Anybody? Quick.
So it has
It can
both
have
magnitude
negative,
and
positive,
direction.
and
Very good. It has magnitude and it is dependent on direction. So we are dealing with motion in a straight line, or rectilinear motion. So direction can be taken care by, yes, direction can be taken care by, come on.
Plus or minus
positive,
sign.
Very
negative,
good.
and zero.
Positive and negative sense. Very good. Okay. So that's what is about acceleration. Okay. So in this acceleration, always remember, when you think of acceleration, always you should think of change of velocity. Always remember, like, this is a keyword. That is, and acceleration means what? Change in velocity. Okay. Change in velocity. Okay. So here it has, there is, There is average acceleration. We have velocity, average velocity, no? Likewise, we have average acceleration also. Sorry. It is denoted by a to the power bar. So average acceleration is nothing but, the definition for average acceleration is change in velocity divided by time interval. Change in velocity. Change in velocity. That is nothing but del V. V is velocity, del is to imply change. Okay. V is velocity. Okay. So del V is equal to what? V2 minus V1. V2 is nothing but final velocity. V1 is nothing but initial velocity. Okay. So what do you mean by average acceleration? Can anybody tell? What do you mean by average acceleration? Average acceleration. Nothing but, we can otherwise call average acceleration as acceleration. Sorry, acceleration over a time interval. Acceleration over a time interval. So for example, as I said, we can say, okay, let's say you're starting a car, you're traveling, okay? You're traveling between 0 to 100 seconds or 2 minutes, let's say 120 seconds. You're traveling for 2 minutes. You have started the car by 0 meter per second and you have changed at 10 seconds. You're going at the speed of, let's say, 20 meter per second. And at 30 second, you're going at the speed of 50 meter per second. Okay. And at the end of this 120 second, you are attaining a speed of, let's say, 90 meter per second. Okay. So there is a change in velocity, right? Change in velocity between the time interval 0 to 120 seconds. So there is a change in velocity between the time interval 0 seconds to 120 seconds. So we are going to calculate what is the change in velocity between the time interval here, that is from 0 seconds to 120 seconds. Okay, so what is the change in velocity between the 0th second to 120 seconds? Okay, so while we are calculating the change in velocity between this time interval, we call it as average acceleration. You understand this? So what do you mean by average acceleration? When we are calculating acceleration, okay, when we are calculating average that is when you're calculating acceleration over a time interval, then that acceleration is called as what? Average acceleration. Okay, so yes, so you're clear with this?
Yes, sir.
Yeah. So we have seen what is average acceleration. Average acceleration, nothing but change in velocity divided by time interval, right? Change in velocity divided by time interval. So that is, change in velocity is del V divided by del T. Change in velocity divided by time interval. So what is change in velocity? V2 minus V1 divided by del T. Time interval is T2 minus T1. Okay, T2 minus T1. So what is v2? V2 we have seen, that is final velocity, right? Final velocity, and this is initial velocity. T2 is nothing but final time, we can say. T1 is initial time. Okay. So as you know, acceleration unit is meter per second square, or meters in second to the power minus 2. So another quantity is there. What is that? Can anyone guess? Another quantity. We have seen acceleration, average acceleration. Another quantity, can you guess? Can anybody guess it?
Instantaneous
Very good.
acceleration.
Instantaneous acceleration. Instantaneous acceleration. That is nothing but acceleration at an instant t. Okay. Acceleration at an instant t. So for example, let's say 0 to 20 seconds. Okay. So this is 1, 2, so up to 20 seconds. So if I calculate the acceleration between 0 seconds to 20 seconds, what is that called? If I calculate the acceleration between 0 to 20 seconds, what is that called? Anyone?
Average
Very
acceleration.
good. It is called average acceleration. Very good. But I want to know the acceleration that happened here, that is at the second. So if I find out what acceleration that happened in this instant, that is the second. Okay. So that acceleration is called as, anybody?
Instantaneous
Very
acceleration.
good. Instantaneous acceleration. Very good. Okay. So what is instantaneous acceleration? Can anybody tell? Define. It is same way as the yeah. Instantaneous acceleration. What is instantaneous acceleration? Anybody?
Acceleration
Acceleration
at
at an
a particular
instant.
instance.
That is okay. To define, like, okay, I can, you can. So what is instantaneous velocity? You know, okay. Likewise, instantaneous acceleration is nothing but limiting value of the average acceleration. Limiting value of the average acceleration. So what is average acceleration? Del v by del t. So for this we are applying limiting value of the average acceleration as time interval del t approaches 0. Del t approaches 0. So as del t approaches 0, we are taking limit of the average acceleration. You understand this? So why del t approaches 0? You know, because we are not calculating the time interval. We are just concerned with that time, that instant. So del t, that is the time interval, becomes 0. So for that we are applying limit. Okay, we are applying limit as del t approaches 0 to average acceleration. So what happens here? Anybody? Acceleration becomes what? Instantaneous acceleration becomes, when we apply limit to the average acceleration, what happens? Okay, it becomes dv by dt, differential coefficient of velocity with respect to time. You understand this? So
Yes.
yeah, instantaneous velocity is nothing but limiting value of the average acceleration as del t, time interval, approaches 0. Why time interval approaches 0? Because we are concerned about that instant only, not the time interval. So del t, time interval, approaches 0. So since del t approaches 0, we are applying limit. Okay, when you take limit, okay, it becomes a differential coefficient of velocity with respect to time. Okay. So instantaneous acceleration A is equal to what? dv by dt. So you're clear with this? Any doubts with this concept, basic concepts?
No, sir.
Okay. So next we'll go with Yeah, we'll see some. I think I have. Yeah, we'll see some graphs. Okay, so this is a velocity time graph. Okay, velocity is plotted against the y-axis and time in the x-axis. Okay, here you have previously seen, no? That is the. I think in your book it is given in the figure 3.3. Okay, in the figure 3.3. Um, or else you can do one thing. You can. Okay, this is a velocity time graph. Okay, let's say this is the velocity of a car, a moving car, velocity of a moving car. It is represented by a velocity time graph. Okay, here what they are saying, that is 0 to 0 to 10. Okay, but before this we can before this you can go for velocity time graph, then you can come back here to understand this. Okay, so first we'll go with the velocity time graph. Okay, let's see velocity time graph. Okay, so that you will understand the acceleration time graph. Okay, so velocity time graph, just you will see the concepts. The velocity time graph. Okay, this is velocity time graph. So that is, the velocity is plotted against the y-axis and time in seconds. It is plotted against the x-axis. Okay, so here there are we have seen the displacement time graph in the previous classes. Okay, let's say this is okay. This is graph one. I'm VT graph. Okay, it is called VT graph. This is graph one. Okay, and this is graph two V. Okay, and this is graph 3 VT. Okay, I'll write this 1, this is 2, and this is 3. Okay, and this is 4. Okay, this is 4, sorry, and this is 4. This is velocity time graph, and this is going to be 4. Okay, and this is 5 VT graph, and this is okay, let's say this. Okay, this is VT graph. Okay, so these are 5 different graphs I have said. Okay, so you can copy it one by one, and we can discuss it one by one also. Okay, so what about the first graph? Any idea? What does it say?
Object is at rest, sir.
That is auxilia, am I right?
Yes, sir.
Okay, listen, auxilia, if it is a displacement time graph or a position time graph, okay, what you said is right about the graph 1, but here this y-axis, it represents velocity.
Yes, sir.
So for example, let's say this is 0 meter per second, and this is 10 meter per second, this is 20 meter per second, and this is 30 meter per second. So now tell me, what does it the first graph say?
So velocity remains constant.
Very good. The body moves with constant velocity. Okay, so likewise, this is the first one. Okay, so this is time, velocity. So this graph is when the object or the body moves with constant velocity. Is everybody getting it, or shall I? Yeah, do you have any doubts in this first graph?
No, sir.
Okay, so everybody is clear. So the object moves with constant velocity. So it is nothing but the slope. The slope should be a the slope should be a straight line. Okay, straight line parallel to the time axis. Okay, slope should be a straight line parallel to the time axis. Okay. Okay. So what about the second one? Any idea?
Object moves with constant velocity, sir, with respect to time.
Okay. What about here? First one you said it is constant velocity. Why you said it is constant velocity, Auxilia? The first one here.
So velocity is increasing in equal intervals of time.
Uh, you're talking about the graph two or one?
Graph 2, sir.
Okay, graph two velocity is increasing with respect to time. That's what you're saying, right?
It's in equal intervals, maybe.
Okay, velocity is increasing in equal intervals of time. So what does it mean? Who said it, ma? Who said it? Who said that answer? Hello? Who said that answer, ma? Velocity is increasing in constant interval of time. Please be bold. I'm not going to see.
So Disha, sir.
Disha, okay. So you're saying the velocity is increasing with in const that is in equal intervals of time, right? Disha, are you with me?
Hello.
Yeah.
Yes, sir.
Okay. What you said is absolutely right. Okay, very good. Okay, what you said is absolutely right. I'll write it here. Okay. So here this is velocity and this is time. So Disha says that velocity is increasing with velocity is increasing in equal intervals of time. It is correct, Disha. Up to 50% it is correct. What you said is 50% correct. Which 50% is this one? Equal intervals of time. But another thing is there. Anybody? See, the velocity is increasing in equal intervals of time. But how is that increasing? That is how far it is increasing. What you have to know here, let's say this is 0. Okay, this is 2. This is 4. This is 6. Okay. And let's say this is okay. This is 2 seconds and this is 4 seconds and this is 6 seconds. So what happens here? Equal intervals of time, no? Disha, this is what you said, equal intervals of time. That is here 2 seconds, here 2 seconds, here 2 seconds, right? What happens in the y-axis? What happens in the y-axis? Here the change is happening between 2 meter per second here. Here the change is what? 2 meter per second here, 2 meter per second. Do you understand? Anybody? Anyone? So the change, okay, there is equal intervals of time. That is okay. The change in velocity is like what? Here, between here to here, it is 2 meter per second. From here to here, the difference is 2 meter per second, and the 4 to 6 meter per second, it is 2 meter per second. So what happens here? There is, I can say there is constant change in velocity. Can I say or not? Correct me if I'm wrong. Can I say that there is a constant change in velocity?
Yes, sir.
What is constant change? That is what is change in velocity?
Acceleration, sir.
Acceleration.
So can I say that it is constant acceleration or not? Correct me if I'm wrong. what you're saying is right. Constant change in velocity is happening. I can say that constant change in velocity is what? Acceleration. So the body is moving with constant acceleration. So this will be the graph. Okay, the straight line inclined to the time axis in velocity time graph. This shows that object is moving with constant acceleration. Okay, this shows that the object is moving with constant acceleration. Do you have any doubts till now? Come on, ma. Do you have any doubts?
No, sir.
Okay. Nobody has any doubts? What about Saumya, Mrinalini, Jayashri? Any doubts? Okay.
No, sir.
Not
Yeah. Okay. Okay.